Move on to the next paper. So the name of the research is Importance of the 5G Network for Construction Sites, Limitation of WLAN in 3D Sensoring Application. And the presenter is Hyung Lee. And yeah, when you're ready, the floor is yours.
The presentation.
Yep, I can see the slide. Yep.
Hi, my name is Hyung. I'm a PhD student here at Chair of Individual Production University. And this presentation is about our study, why 5G network is important for construction sites. So nowadays, as we have seen in our prior presentations, we can find always more emerging technology, such as digitalization or automated machines on construction sites, because they provide significant opportunities for the industry and the involved human workers. However, one fundamental requirement for this new technology is that the communication must be stable. In robotics, the communication to the robot must be stable and fast. Also from the IoT application side, the on-site network must be able to hold out multiple users and devices at the same time. And especially for time-critical applications with machines and robots, this stable communication is very important. As for example, in a dangerous accident situation where the machine has to touch the human workers, every second, even every millisecond counts. At the same time, it is also very important to have an on-site network with a huge bandwidth. In this slide, you can see teleoperated machines controlled by human workers. And as you can see, these human workers are wearing safety clothes and even masks, but they are still working on-site directly to the machines because they have to observe the work area. Simple 2D cameras are often used to provide visual information to the operators, but these 2D cameras are not sufficient as the depth information is missing there. So depth camera or 3D LiDAR is another alternative. But as this is 3D information, the required data volume for this device is much higher. So the human workers have to work on site, just next to the machines, potential risks. The vision of this project of our care is to establish a robot 5G network for our construction site in Aachen to enhance the overall efficiency in teleoperation. So before we actually deploy and install the 5G network, we need to know the use case related aspects such as the required bandwidth. So in this work, we have done a couple of tests with our mobile robot to identify the requirements, and at the same time also we show where the limitation of a wireless LAN in terms of 3D sensing application lies. This is the general setup of the experiment. The mobile robot is equipped with a depth camera, 2D LiDAR, and image measurement unit, and can wirelessly accept signals from the user. Communication to the user and the control PC is established by a TCP/IP-based robot operating system. In our first experiment, we have done the latency test in 3 different conditions. Basically, we sent the control message, which was of the size 10 kilobytes, and have measured the time that this message needs to travel from the control PC to the robot. In the first test, the latency was around 1 millisecond, so almost equal to 0. And when the maximum bandwidth of the network was used for 50%, the latency was increased to 5 milliseconds, and the full bandwidth, around 200 megabit per second, was used. The average latency was measured as 150 milliseconds. So in this simple test, you can see the importance of the latency and the network bandwidth for time-critical applications with on-site construction robots. Nobody wants that the control signals arrive at the robot after 150 milliseconds, right? So also in the next test, we have measured the time that the mobile robot needs to send the visual information, in this case the point cloud, to the user while it drives away from the router. Here we have used a pre-recorded point cloud of size 29 megabytes to keep the data size constant throughout the test. Yes, the test result shows that the latency dramatically deteriorates in line with the distance from the router. The construction is about changing the environment. For example, in building construction, the building rises with the time, so the area that the network has to cover changes with the time. According to this test result, we cannot rely on the routers that are stationary positioned, because then the performance again decreases according to the distance to the router, according to the construction process. So yes, of course, one can say we can extend the wireless LAN with a lot of access points, but then one will still have the network instability in this between area of the access points. Yes, so in the last experiment, we actually captured the environment in 3D with our depth camera and sent it to the operator in real time. The goal was here to identify the trade-off between the visual information quality and the required network throughput. So here the point cloud was generated with 3 different resolutions: 1 centimeter, 0.5 centimeter, and 0.2 centimeter. The quality difference can be clearly identified in this figure. So during the test, the robot drives to the goal object, this concrete block along the predefined trajectory. Yeah, 3 different. So we did this test 3 times with 3 different resolutions, and we have measured the average message size and the resulting data. Information is of course helpful for the operator as it has depth information, but still the operator does not have the opportunity to analyze the captured information, as the information is not stored anyhow. So it is just gone whenever the robot moves away with the camera. So we also have created a 3D map with the captured 3D information, key points of the captured frames and stitching them together. So yes. Once this map is created, the operator can stitch them together and one has a more clear 3D map. And the operator can now rotate the generated map and zoom in, zoom out to analyze the work with more in detail. Yes, the result of this test is then summarized in this table. So with an average wireless network with maximum bandwidth of 200 megabits per second, the full bandwidth was required to transmit the point cloud in a high level quality of 0.2 centimeter resolution without any delay. One could think this is enough, but usually the normal 2D images are transmitted in parallel to the 3D information, as there are also features that can be better recognized in the normal 2D images. Then the network is already overlooked. So having this result as our baseline, our vision is to develop a robust on-site 5G network to enhance the overall efficiency in the operation. Yes. Thank you. That would be the end from my side.
Thank you for your presentation, Hyung. Even though sometimes your audio is jumping a little bit, but yeah. Anyway, any questions from the audience? Okay, then I would like to ask a question about the potential use case for this technology you described. So what would be the most optimum, let's say, use case on site you could imagine? Like, who would be the first target customer to deploy this technology in your mind?
Actually, we are targeting the teleoperated machinery. So if you think about how this teleoperated machinery is deployed currently on the construction site, one just uses just normal 2D camera images without any depth information, which is very critical for accurate for tasks that require accuracy. So providing their 3D information with the 5G with the on-site 5G network would be then our first use case.
Okay. One more question then. Is there any, just out of my interest, is there any privacy issue in terms of scanning a human worker on site? Have you ever come across any potential, I don't know, inquiry about privacy about the actual on-site personnel showing their, I don't know, their faces or whatever?
A good question, but actually, as you have seen in this presentation, we are targeting at the deconstruction task. So there, in the ideal case, there will be no human workers around this deconstruction area. So there will be one deconstruction robot. There will be one mobile robot which is capturing the work area and sending the information to the operator wirelessly, who will be then sitting in the control center. So yeah. So
okay.
In an idea, yeah.
Yeah. Okay. Great. Yeah. Thanks for your presentation. Then yeah, let's move on to the next one. Thank you very much.